Mathematical induction. Mathematical induction is a proof technique used to prove that a statement holds for all natural numbers. The principle of mathematical induction is: suppose that we have a statement. We have a statement about a positive integer n. If we can show that number one, the statement is true for n equals one. Two, when we assume that the statement is true for n equals k, we can then show that it is also true for n equals k plus 1. Then the statement is true for all positive integers. For example, there is a statement following. This statement is 1 plus 3 plus 5 plus 2n minus 1. This equals n squared. For example, this is a statement. If we can show that this statement is true for n equals 1, and then we assume that the statement is true for n equals k. If we can then show that this is also true for n equals k plus 1, then this statement is true for all positive integers. Now we just show how to use the principle of mathematical induction to prove this statement. First, we can rewrite this statement as this: sigma r equals 1 to n. Here is 2r minus 1. This equals n squared. So this is another form of this statement. So when n for n is 1, then the left hand side equals sigma r equals 1 to 1. There is 2r minus 1. So this equals 2 plus 1 because r is 1 minus 1. This equals 1. This is the left hand side. And the right hand side equals n equals 1. So this is 1 squared. This equals 1. So the left hand side equals right hand side. So this statement is true for n equals 1. Now, step 2, we assume that this statement is true for n equals k. So we assume that this one is true, n equals k. Then 2r minus 1 equals k squared. We assume this is true. Then we use this as a condition to prove that when n equals k plus 1, the left hand side still equals right hand side. So we assume this exists. Then for n equals k plus 1, the left hand side equals sigma r equals 1. Here is k plus 1 to r minus 1. This is left hand side. And this equals r equals 1 to k to r minus 1. Plus, this is 2 multiplied k plus 1 minus 1. Now this is our assumption. This is our assumption. So we can use t squared to replace this guy. So this equals t squared plus, we remove the brackets. This is 2t plus 2 minus 1. This equals t squared plus 2t plus 1. This equals t plus 1 squared. 1n equals t plus 1. The right hand side just equals t plus 1 squared. So for n equals t plus 1, the left hand side still equals right hand side. They are the same, they equal. So the statement is also true for n equals k plus 1. Here we assume that this statement is true for n equals k, and we use the assumption as a condition to prove that the statement is also true for n equals k plus 1. Now, because the statement is true for n equals 1, and if it is true for n equals k, we can show that it is also true for n equals k plus 1. Therefore, this statement is true for all n belongs to the positive integers by the principle of mathematical induction.